Okay, this is A2Pure Maths. We're on chapter 2 and we're looking at trigonometry, and we're taking a wee look then at the expression A cos theta plus B sine theta. Effectively, we can look at the A and the B and set them up as Pythagoras, find the square root of A squared plus B squared, and then take that out as a factor and divide through by that. This all looks terribly complicated. It makes a little bit more sense if we just kind of run through a few examples, and then I can hopefully then kind of refer back to these bits and pieces then as we see them. So just as we look at this one, say for example, consider 3 cos theta plus 4 sine theta. So if we take out a 5 out the front and then divide by 5 in there, then we get a 3/5 cos theta here and a 4/5 sine theta here. The cos theta here and the cos theta here are equivalent, so we can let then our sine alpha equal 3/5 and our cos alpha equal 4/5. So sine alpha is 3/5 and cos alpha is 4/5. So if we look at that then as our angle, so alpha is sine to minus 1 and 3/5. So just take an inverse sine, cos will be the same then, 36.87, and we end up then with that there. So if we take this, means we can write this then as 5 sine alpha plus theta. That's the same as 5 sine theta plus alpha. Unsurprisingly, this is the same as 5 sine, let's change the light here a little bit, 5 sine theta plus 36.9 degrees. So sometimes you're asked to write this in the form r sine theta plus x or something like that. Another way we could change the same thing, so 3 cos theta plus 4 sine alpha, is we could set it up as, let's see how we are for space here, so 5 on 3/5 cos theta plus 4/5 sine theta, and we could see that that then is equivalent to the cos one. So if we have cos alpha cos theta minus sine alpha sine theta, then in this case cos alpha would be 3/5 and sine alpha would be 4/5, which gets us in the other way around, and so our angle then is sine to minus 1 of 4/5 or cos to minus 1 of 3/5, which gives me 53.13. This here, we're going to let this equal this, so it's going to be equal to 5. I'm letting the 3/5 be cos alpha, so that's cos alpha cos theta plus sine alpha sine theta. Sorry, did we mistake up there? That should have been a plus. I was getting mixed up with the next line. And then that's theta minus alpha. If you remember from the formula, remember the way the plus gives you the negative one there. And that gives you 5 cos theta. Sorry, after all that, minus 53.1 degrees. Another one we need to take a wee look at then, maybe say we had 3 cos theta minus 4 sine, that should be a theta there as well. We could rearrange that as 5 upon, same again really, 3/5 cos theta minus 4/5 sine theta. And we have our minus here, we have our minus here, so that's going to be the same then as cos alpha cos theta minus sine alpha sine theta. Gives us 5, should have a 5 there. Alpha plus theta which is 5 cos theta plus alpha, which is 5 cos theta plus, and in this case my 3/5 is the same as cos alpha, my 4/5 is the same as sine alpha, so that's a 53.13 in that case there. If we take a quick look back, this is a generalized form of it there. Where did we get the 5 from? It was the square root of 3 squared plus, well, here. Where did we get the 5 from here? Remember we took the 5 out the front. It was the square root of 3 squared plus 4 squared, which we're getting there. So say we had 3 here and 4 here. 3 squared plus 4 squared, square root then gives us 5 using Pythagoras. And then we can find in some of the other bits and pieces like that. So if you have a cos theta plus or minus b sine theta, you can rewrite that as the square root of a squared plus b squared cos theta minus or plus alpha, and then there's sine versions of that then as well. So that's our harmonic expressions, a cos theta plus b sine theta.